So in the last problem, we found average rate of change between two different times, like 3 seconds and 3.1 seconds, that type of thing. Now we're going to find instantaneous rate of change. So remember, if you are doing average rate of change, average is for algebra, instantaneous is for calculus. So all I did was fill in the difference quotient, and I changed my t's to x's. You can leave them as t's. I just did it that way because I can. Okay, so what I have now is, here's f of x plus h. So wherever there was a t or an x, I put an x plus h, minus your original function all over h. And I'm taking the limit as h goes to 0. So once again, what are you finding? This is slope on steroids. They've already subtracted off your x2 minus x1 and effectively have 0. So you are looking at points that are right smack close to each other. Okay, so I'm going to FOIL this out, combine like terms, all sorts of good stuff. So I've got the limit as h approaches 0 of, this is going to be a 128. Well, fabulous. This is going to be a 128 x plus 128h minus, okay, remember that this is x plus h times x plus h. So you need to FOIL that out, and that'll give you x squared plus 2xh plus h squared. And now I'm going to distribute that negative 16 through. Okay, so a negative 16 times x squared is a negative 16x squared minus 32xh minus 16h squared. And now I'm here, so I can just distribute that negative. So minus 128x plus x squared. Okay, so what do I have now? What I have now is, okay, I just caught a mistake. My original function was not 128 minus x squared. It was 128x minus 16x squared. So I forgot the 16 here, and I forgot the 16 here. Okay, but I've now fixed that. So what can reduce? I've got a positive 16x squared here and a negative 16x squared here. I've got a negative 128x. I got a positive 128x. And then I notice that everything in the numerator that's left all has h's. So I can reduce an h here, here, and here. So when I get that, I have the limit as h approaches 0 of, reduce that, and I'll get 128. Reduce this, and I'll get a negative 32x. And reduce this, and I'll get a negative 16h. So now, can you take the limit? Yes, I can. So wherever there is an h, I'm going to put a 0. So he's unaffected, he goes to 0, because negative 16 times 0 is 0. So now your formula for slope, instead of being in algebra world, which would look like this, your formula for slope for this specific curve, okay, so your formula for slope on the tangent line, or the formula for instantaneous rate of change, is now 128 minus 32x. So my slope is going to be 128 minus 32x. So the instruction said find the instantaneous rate of change when t is 3. Okay, well remember that we are in t world and not x world. Okay, so t is going to be, you can't see, t is going to be 3. So m equals 128 minus 32 times 3. So 32 times 3 is going to be 96. Okay. And then I'm going to subtract 128 minus 96, and I'm going to get 32. So my rate of change is a positive number. My rate of change is a positive number. So because it's positive, that means it's increasing. Okay, my instantaneous rate of change is positive, so it's increasing. Well, what happens if my time is 7 seconds? So I'm going to shove a 7 in. I got it 128 minus 32 times 7. So what do I get there? 128 minus 32 times 7 gives me a negative 96. So what does the negative mean? That means that the velocity of my ball is now going down. So that means it's decreasing. Okay, it's decreasing. So I have negative 96 here. Well, then what I'm asking is it rising or falling? This is going up. This is going down. Okay, this is going up. This is going down. So you can kind of envision your ball going like this. Over here, it's increasing at a rate of 32 feet per second, whatever it is. Over here, it's decreasing at negative 96 feet per second. So when is the ball going to hit the ground? So this is where we want to start taking, I got a 128 minus 16. All right, so this is your position function. 128 minus 16 t squared, okay? So this is your position function. And so what we'll start referring it to is S of t. Where do you start? Okay. So I got 128 minus 16 t squared. Your first derivative on your position function will give you velocity. Okay, so your first derivative will give you velocity. So that's when you apply the limit process to the difference quotient. And that gave me a negative 32t. So that's your velocity. Okay, so if I'm asking when does this thing hit the ground, since I'm talking about a location, I need to use my position function. So what level is the ground at? Well, the level of the ground should be at 0. Okay, so the top of the ground will be at 0 feet. So when will this thing hit 0 feet? Well, I'm going to add 16t squared. So I get 128 equals 16t squared because I added it to both sides. Then I'm going to divide both sides by 16. Okay, so 128 divided by 16 should be, crud, I just did that backwards. 128 divided by 16 is 8. Okay, so I get 8 is t squared. And then from there, I want to know, I'm reading if it's wanting you to give an exact answer or if it's wanting you to round. It doesn't say. It just says how many seconds. So I don't care what t squared is. I care what t is. So I'm going to take the square root of both sides. Remember, any time during the process of solving a problem that you have to take a square root, do not forget your plus and your minus. Okay? So this becomes the square root of 8. Well, the square root of 8 is effectively 2.8284. So plus or minus 2.8284 seconds. Now, only one of them is the right answer. Because this is a negative answer, I cannot go back in time. Okay, so my time is going to be 2.8284 seconds positive. Okay, it's only going to be positive because the ball has to travel, and so it's roughly just shy of 3 seconds. So you're going to ignore the negative answer. You will ignore the negative answer. Okay, so that is how you're going to start solving these things. Now, you may be ready. I'm like floating through here. Okay, so you've got that one that you can do. You've got that one you can do. Okay, so we're going to round this out just because I want to start talking about, because the rest of those, you can follow that same format. And if you have a question, just email me. But I want to talk about notation because you're going to see it in this homework section as well as we're going to be using it an awful lot. So when we talk about a derivative, in its most fundamental meaning, we're talking about instantaneous rate of change. Okay, instantaneous rate of change. So in the business world, you're going to find out that that has applications with your marginal revenue or your marginal cost or anything like that. In outside of business, you could say, you know, how is that? Remember, we talked about the roller coaster. How is the roller coaster falling at exactly this moment in time? What is its rate of change? And you should know at this point that it would be negative because it's falling. Okay. So the notation that we're going to use, if we have equations, then I can have my original function, or I can say its derivative. So it's just like a little apostrophe. It's a little tick mark. Okay, so this is my original function. This is my derivative. I could just as easily say y and then y prime. okay, or the derivative of y. So I'm telling you to do something from here to here. If you see y equals 3x plus 4, so this is a line, you should already know that your derivative is 3. Okay, when I see this, this immediately says, okay, tell me what my derivative is. Well, your derivative is your slope, and the slope of a line is 3 all day long, of this line. Okay, other ways that we can do this is we can say dy dx. So I'm playing with y's and I'm playing with x's. So please take the derivative of y, but you're playing with x's. So this is just a notation that we'll get further familiar with later on. You'll also, which I have yet to see it in a math class, you'll see this format, which this is like a little subscript, almost like an exponent but lower. Okay, so this would say take the derivative of y in terms of x. And again, I have yet to see that in my discipline. Now, you may see that in physics, you may see that somewhere else, but as far as in math or as far as what we're doing in business calculus, you won't see it here. So just know that that's how we're going to tell you. If I show you that, you know to add. If I see that, you know to subtract. If I say this, you now know, please take the derivative. Okay, so that is, I'm going to leave the last few word problems for you. Just remember, if it says average, you're going to use algebra. And if it says instantaneous, you're going to have to use the limit process. Okay, so you are now ready effectively for your first test.